Welcome to our presentation on Deskbot, the virtual receptionist. My name is Damien Jawahir. I am your presenter, and I have worked very closely with Jaleel Mohammed, Tristan Sukram, and Dylan Brito. What is our system? Our system is a virtual receptionist aimed at universities. It allows persons to go to the virtual receptionist and ask it questions on common tasks so that it can alleviate stress on human receptionists and provide the most accurate information to students and customers. When our system takes into consideration the need of the modern students, staff, and guests as of the concept of the project. In many universities, a large portion of office time is used to assist persons with the same repetitive task, which the system aims to correct by having these tasks done autonomously. Our proposed system is currently being developed to cater to the front desk of a university where a large amount of students, guests, and members of staff tend to have a large amount of repetition of questions and answers. However, the system can also be implemented in businesses easily to help with simple tasks. Why? During research on office inefficiencies, we found one place where most information is either lost or the most time is wasted is at the front desk of any university. This led us to develop a concept which, when implemented, will allow offices to have a large improvement on efficiency and information accuracy. Repetition. You may have noticed the previous slides featured repetition to a large degree. This was to show to everyone the importance of how tedious repetition can be and why I believe the system can be beneficial to an office. Requirements of users. Our system has four main users: the staff, student, guest, and admin. Onto the student can request to view buildings or classroom locations. Student can request meetings with staff. Student can view academic standing. The student can access information on currently pursuing degree and find suggestion for courses recommended by staff. The staff can add locations to buildings or classrooms. The staff can add information on degrees and programs, and the staff will be sent a notification when students or guest requests are made with a meeting with them. Guests can access locations of buildings or classrooms. Guests can look at and apply to degrees and programs, and the guest will be the default profile unless a user logs into an existing profile. The guest will be default if the system cannot access user information. The admin can access all programming information and how the system functions. The admin can make any changes needed to the system, and the admin can access other users' data. Onto the system requirements. User login, or if not registered, a guest account in order to treat each person differently. It has access to a database to receive data for each user, open source facial and voice recognition software. A log will be kept of all persons when the system was accessed, detailing the time and information requested. If facial recognition was to fail to access another user through facial recognition, it will request user to log in using randomly generated code sent to the user's email address. In the event of issues outside of the system will default to a guest so that it is still partially functional. All parts of the system should be independent, so in the event one part needs to be updated or disabled, it does not compromise the system, and the system should be simple to update, allowing for updates to any individual part of the system should the need arise. The system should not display any information without the user being logged in, and the system shall use store-bought hardware. The system shall store database entries and change offline as well as online, and the system will automatically update. Onto non-functional requirements, performance, an interactable real-time system such as this one would need to have adequate performance levels, which include characteristics such as quick response time, throughput, processing speed, and no lag time. Security, the system utilizes users' personal information, and therefore security is a must. If the system isn't secure, then information can be used wrongly or maliciously by others. Hence, users expect the system to be secure and should allow them to log in and log out with ease. Usability, it will make no sense to have an overly complicated system where users are unsure about how to work it. The system is geared towards assistant clerks and advisors and should therefore be easier to use than asking a question. Hence, an easy and friendly user interface should be provided to ensure usability. Capacity, the system should be required to handle heavy loads of frequent requests as it is expected to be occupied very often, especially if used at a university or school. Availability, ready for use when it needs to be used. This is a concept that the system should follow as it is expected to be needed for use a lot, and hence it would need to be used if a user is depending on the services of the system and it is unavailable. Functional requirements, authenticate the user via facial recognition. If facial authentication fails, send a verification code, the user's email, and or voice verification. If user is a guest, the user can access general information and provide guidance to potential students. If user is a member of staff, the system can allow the user to add a student. The user can add or remove course information. The user can access a database to retrieve and change data. The user can set requirements. The user can enter office hours. The user can make appointments, and the user can accept or deny appointments. If the user is a student, the system can check user data such as students' academic standing and academic courses. The system shall assist in registration processes. The system shall be able to advise students on courses they can or need to pursue at the given time, schedule and or suggest appointment date and time with staff. The system shall log all interactions. This is a context diagram showing the virtual clerk, the scanner, user, staff or admin, messaging service, and the users and how they interact with each other. This is a use case of the actors which we have outlined, which we have found the student, admin, database, staff, the scanners of both facial and voice recognition, the guest, and the messaging service. And these are the important use cases which show the secure login, get directions, view general information, view student information, receive academic advising, schedule appointments, manage appointments, update course information, and registration of a student. This is a use case diagram which shows the various actors and how they interact throughout the system. This is the use case rankings which show each different use case and their priority as comparative to each other, where certain things such as the secure login is ranked as very high, as is very important to the system, while certain things such as the updating of course information is very low, as it is not very important to the priority of the system, as we have much more important parts of the system. For the use cases, we have extended use cases which show the first one being security requirements, where this use case describes when a user logs into a system, the user scans his or her face on the facial scanner for verification to access the system with their account. If the facial scanner does not work, an alternate login will be optional using demographic information in the database. And if successful, the user will gain access to their account. One thing that we assume with this is that the database contains all necessary information needed for the system to function properly. And one open issue is that the login may fail, therefore we may have to have an external authentication. On to our second use case, we have the update, which shows a description that this use case describes when some information is given and makes changes to update the database. The information is validated to ensure no errors occur. Once approved, the information is updated in the database by the system where necessary. One assumption is that the system has administrative and editing clearance to update the database as needed, and an open issue is getting access to the database. Here we have the class diagram, which shows the different various types of parts of the system and how they interact with each other, such as the users, where they interact with the recognition system, the virtual clerk, the guide, the scheduler, and the appointment systems. Onto the risk management, we have several risks. The first risk that we will outline today is the risk of hardware unavailability, where the probability is very low, the effects are catastrophic, and it affects the project. One strategy category that we have choice is the avoidance category, where we have the strategy of sourcing several companies to get hardware beforehand. We have product competition, where the probability is very high and the effects are very tolerable, but it affects businesses, so we have chosen minimization. We have a plan to deal with new competitors in the market by employing specific measures which put product ahead of its competition. We have the unauthorized use of a system, which the probability is very high and is very catastrophic to the system as it affects the security. So we have threat avoidance, where the system will have security checks and encrypted code to ensure unauthorized access and hacking is difficult to do. We have problem with the productivity issues, where the probability is very high, effects are serious, it affects the project and the product, so we have chosen avoidance. So we have a strict project manager to ensure that employees meet the schedule and be as productive as possible. And we have the compromising on design, where the probability is low, the effects are tolerable, and it affects the project and the product, where the strategy category is a contingency plan, and we use an agile methodology for designing software to cater for change in designs as needed. On to cost estimation, we have chosen the COCOMO model. Firstly, the COCOMO model allows one to estimate the cost, effort, and schedule when planning new software development activities. It consists of 3 submodels, each one offering increased integrity. The further along one is in the project planning and design processes. Here are the results that we found from our COCOMO model, where we found the effort to be 22.0 person months, the schedule to be 10.2 months, the cost to be $175,808. The total equivalent size will be 5,000 SLOC. Under the COCOMO software size, we have found that certain parts of it, whereas the required software reliability was carded as being very high, whereas the platform experience was seen as being very low. This was due to the way that we have designed the system. And this is the reasons for the COCOMO software size being as is, where many of the choices made when using the COCOMO model was based on analytics from our observations and where focus needs to be put on our software. As such, parts of the system, such as the software's reliability, was placed on a high requirement as the system needs to be reliable to perform its actions effectively. However, certain parts of the project, such as platform experience, was placed on lower requirement, as requirements such as training is not necessary for the use of this system, as the system will be designed in such a way to allow a person who has never met this system before to automatically be able to use the system without any assistance. This is a bar graph from the COCOMO model, which shows the people compared to the months of the system, this development cycle. This is the COCOMO distribution, which shows a phase of inception, elaboration, construction, and transition, with comparison to the effort, schedule, average staff, and the cost of the project. This is another part of the distribution, which shows the phase and activity of management, environment, requirements, design, implementation, assessment, and development, with comparison to the inception, elaboration, construction, and transition of the system. This is the closing statements. We would like to close our presentation with thanking those viewing our project. We would like to believe that our system can be beneficial to any potential customers, as it will be able to both improve productivity in the office, as well as we believe our system will reduce cost placed in front desk with unnecessary workers. This is the end of our presentation. We thank you very much for listening.